how do you choose the correct type of function, the correct model for a set of data? For example, in this situation, this graph represents the distance needed for a car to come to a stop based on the speed it is traveling when the brakes are applied. So here's the speed on the x-axis in miles per hour, the stopping distance in feet on the y-axis. We have 2 points on this graph. If a car is going 50 miles an hour, it takes 250 feet to stop. If it's going 175 miles an hour, clearly speeding, it takes 2,000 feet to stop. Now this data doesn't really give you any sort of shape to go by, so you have to use some common sense. Which type of function, linear, power, exponential, or logarithmic, is probably the best model for this situation? Why? Well, let's think. If we had a linear graph, what would the line look like if I drew it down through these points? Notice that we have a negative or a negative y-intercept. That means if the car is going a negative number of, or if that car is going 0 miles per hour, it will have negative stopping distance, basically going backwards. That doesn't make any sense. Let's try power. Power would go through 0, 0, because this is clearly an increasing power function. It would look like that. Power goes through the point 0, 0. That says when a car is going 0 miles per hour, it would have 0 stopping distance. That makes sense. Let's try exponential. Exponential does not go through 0, 0. It would go through the y-axis a little bit higher. That means when the car is going 0 miles per hour, it would have to have some stopping distance. That does not make sense. Log would do this. That has an asymptote saying that a car couldn't possibly have any 0 miles, it wouldn't even go 0 miles per hour. Now this function might fit okay for larger numbers of miles per hour, but it looks like power makes the most sense. I would choose the power function. The power function makes the most sense in the context of this problem because a power has the correct y-intercept. A car going 0 miles per hour, which is the x value, would have a y value of 0 foot stopping distance. If we were to put that point 0, 0 on here, we can also see kind of the curve shape that fits a power function nicely. So using common sense with the y-intercept is one thing you need to do. Now most of the time you're going to have more than 2 points. You're going to have a whole set of data like this. So on this graph you could look at this downward trend and you can say, oh, that could be a decreasing power function with a negative exponent. Or this could be a decreasing exponential function with a base that's less than 1. How would you choose the correct model? Well, either one could fit this data nicely. So checking the shape of the scatter plot narrows it down to power or exponential. Then what you'd want to do is look at the difference between the decreasing power, which would look like this, and the decreasing exponential, which would look like this. One of them has an x-intercept, the exponential function, and the other does not. They both have a similar asymptote at the end. Which would make more sense, having an asymptote and no y-intercept or having a y-intercept? Well, you'd need to know more about the context of the problem to figure that out. And this problem, this air pressure and time problem, happens to be one of your homework problems later on, so you'll be making that choice later. So, to summarize, check the shape of the data plot, the scatter plot, pick an appropriate function based on its shape, and then narrow down. Actually more than one function usually will fit, unless it's clearly linear, and then check that the y-intercept and asymptotes make sense in the context of the problem.